They do. Yep. Yeah, it's all very, very clear. Once you see it line up, where everything lines up should be pretty apparent. You know, pilot holes line up and they don't look like crescent moons. Rafters always get split by 16 on center studs in the wall. So ceiling rafters, you got 2 of them. You're going to have a vertical stud that's splitting that center line of those in the wall. So if you're looking at your top plate, for example, you're going to have half of the rafter and half of the rafter in almost every layout configuration because it's typical 16 on center IRC framing. So if you, that's okay, it's still enough of a layout. This roof will get split by 1 stud below the top plate of its wall that it's sitting on. Does that make sense? Another thing to look at is the screw locations. You can actually use those as kind of like X and Y coordinates when you're getting stuff to line up during the assembly process. Like I said, you know, the drawback to everything in CFS is that it's very, very linear, very 90 degrees. There's no miter cuts or angles or anything to speak of that we can manipulate. But that's also what allows us to check our work throughout the build process very, very efficiently and quickly if we know what to look at. Square is square, plumb is plumb, and level is level. Those things are non-negotiable, right? Well, there's extra little indicators throughout the build that will let us check that throughout the process. Any other questions on this before we move forward? Wow, that was exciting. Okay, next.
Brent has a question.
Shoot.
Oh, about blocking? What?
Sure. Is that your question?
No, I thought you asked me to.
Oh, no, because he was talking about.
Somebody has a question on blocking.
Well, so we are planning on blocking.
Don't.
No, don't? Okay.
I already did.
Like 1 foot from the edge, blocking in between each member so that we can screw in the folding portion of our roof and have a sturdy attachment. So we would stack 2 2x6s as blocking.
I think it could help.
Yeah, just use hybrid clips in the rafters.
So
You can use pocket connectors in the rafters.
Yeah.
Go ahead. Let's hear
So,
it.
I mean,
I'll come back to
that
that.
these bolts are set back 1 foot from the roof edge, and then they go through the blocking
Is
into
this
our entire roof.
is this more than the depth of the roof? So we're
No.
going through top and bottom?
Yeah, we're going through top and bottom, but since the 2x4 is 3 inches thick, so they'd be sticking out an inch on the other side, but then it'd be flush with the
Plus you finish materials on either side? Okay. So what do we think? 4, 4.5? Is the total hole length there?
3, but it's.
Okay. Yeah. That's perfectly good. So use a clip or a connector that allows you to put, let's take a pocket for example, like on a rim joist, you can put a floor over a basement. You get your rim joist standing up around the basement hole, right? And you get all these steel connectors and you're going to drop 2x12 floor joists into, and then nail them together into the corner connections. You can do the same thing here and still use wood to make amendments to the CFS framework. That stuff's easy. I just need to visualize it. That's great. Yeah. Blocking only for this, it's attachment blocking, not structural blocking, is what I was asking. Okay. Yeah, these are just attachment points for the awnings. Yeah.
That goes for electrical.
Huh?
Electrical boxes and things like that as well. Like you can hear like wood pieces and puzzles that you can
Attach your J-boxes to the studs. Yeah. You just screw and set nail it. Use a couple of tech screws. Yeah, it's the same. Most most of it won't be any different between wood and steel, other than how they hold themselves together. But how they build out will be very, very similar. Yeah.
Mike, you had a question about, or is Spencer as well, about how to run electrical through the header. Wasn't that how you?
Yeah, then we were gonna basically on that center wall, like basically directly over.
Here?
Yeah, it'll be like, it'll be just below that header. Because
Can you use it as a chase?
Can we drill a hole through the header? Is that what we need?
You just need one stub out, right? Or a few?
Yeah, we might be doing that. I think it's just.
Totally okay.
Okay.
Yeah, you can do, because you're
So
gonna have
we-
lighting up here, right?
Yeah, I think we might go from the bottom for this, so, yeah.
Remember, that's an I-beam, so
Right.
it's completely open faced.
Right.
And it's even got a channel that you could run Chromax through it if you want, yeah. If there's a question on structural integrity before you penetrate through something that you're not sure about, call before you dig. Just give us a shout, you know? Sort of same thing. Hey, is it okay to, if you say, can I put a 6-inch hog through that? I'd go, let's maybe look at a different solution first. But you got some wiring options in there, and there's a lot of utility holes that we punch these, so there should be some solutions without wasting a bunch of copper.
Are you using torque wrenches for the strong side and the bottom stuff that always is what you're saying you use almost like mini drill press for?
Uh-huh.
Are you using a torque wrench?
Yep. We torque them to 140 pounds. Between 110 and 140 is what Simpson told us. So it's a little harder. Actually, it's not hard. It's a little easier for us to get 140 because we're not squishing as much. We got 3/4 of engineered wood product as opposed to 1.5 2x4 plus, you know what I mean? So some of those guys they stop at 100, 110 because they're probably not going to get to 140 before they turn it into kindling. So we go to the top, to the higher end.
Back to like the wood that we were talking about before, side to side with the axles.
Yeah.
You know,
We understand that we want this to be, the loading to be somewhat evenly distributed. Do you know, like, within a range of X percent, or?
I'd say don't go more than a third heavier on one side than the other. And then all it does is truly on our chassis, we've done a lot of work. We know where to put the tongue so it pulls a certain way. We know where to put the wheels, the weight, so that it pulls a certain way. And we do that to an nth degree, to a proprietary degree, so that more times than not, no matter what you put on it, it will still go safely down the road. I can't say that somebody hasn't challenged me before, because if you don't stay within the guidelines, then all bets are off. 14,000 pounds max means 14,000 pounds max. That doesn't happen very often these days, but back in the dark ages of the tiny house world, we were still kind of all figuring this stuff out together. So the weight distribution from one side to the other isn't going to affect how it sits on the ground. It's only going to affect really how little or how much it wants to be affected by the road it's being towed down. You guys know there's crowns in the road. The older the road, the more it kind of feels like kind of driving in a ditch, really. Low distribution laterally will help it crawl to one side or the other, kind of like an alignment problem on your car or truck. It'll maybe just want to creep to one side a tiny bit, not even really tangible, but enough that you'll sit here and kind of feel it correctly. When high wind situations or really crummy road situations like that big crowning, that's where that will rear its head. Other than that, if this was 50% heavier than this side, it might sit a 1/4 inch low on one end and wear out the left tires a little faster. But that's really all. Don't go so crazy on the low distribution laterally, because it's only 8 feet, and one wall is only a foot or two shorter than the other wall, so it's not that big a difference. I think our differential here is probably not more than 10 or 15% from left to right, and we figure 30% on our designs. So I'm going to call that a moot point.
Cool.
But did that explain where we're targeting? We don't want one side to weigh more than about a third. That's our red line. That's how much more one side can weigh than the other.
And then front to back, and we've got, the only, up towards the front of the trailer, we're looking at the back right now. So that's where the brake lights will be, where that shelving is back there.
This is the rear.
Yeah.
Okay.
And then this is the front. We just have a door, and at this point, nothing at the front. Just in terms of front to back distribution of weight, we know we want the 60-40, and we want to have the downward pressure on the axle, or not the axle, but the
Tongue.
The tongue. Given that the wheels are placed where they are in the trailer, does that correct a lot of the imbalances?
That is exactly where they are placed for that reason. The rule of thumb is roughly 60-40 load distribution. So if you can go back to where you had the fender box, yeah. So right here in the middle, you got a wheel here and a wheel here, right? In the middle is what we call the axle center line or load bias center line, and that is where you put your running gear in relation to the length of the tongue, the overall vehicle, or the cargo deck of the vehicle itself that you're building. So knowing the tiny houses are extremely heavy, we move that forward a little bit so that it's not so heavy on the tongue, because tongue weight is good until it's not. So law of diminishing returns takes over at some point. You got 6,000 pounds of tongue weight on the back of your truck. Well, it's not going to fishtail a whole lot, but it's going to drag the back of your truck down the highway probably. So we want to be middle of the road. What about 10 to 15% tongue weight? So if that's a 10,000 pound structure, we want between 1,000 and 1,500 pounds on the back of the vehicle. Okay? So that's a pretty substantial vehicle, 3/4 ton, 1 ton, 1.5 ton pickup. Those of you who saw us drive in this afternoon are one of our shop trucks. It's a 3,500 diesel dually. It's purpose built to move these things around and not really break a sweat. The heavier they get, the heavier a truck you need. This is a pretty small, pretty sparsely designed structure. I bet a 1/2 ton will pull these pretty effectively.
Just Duna, one of these.
You got a bill of materials weight?
No, we don't. We didn't go through that process of weighing
Yeah.
out everything.
Raise your hands if you're going to be the volunteer to add all the weights up every. No? I'll let you pick it.
Yeah.
It's important,
we
guys.
just-
The reason I say that, you should know, because we have limitations. We have tires, we have springs, we have axles, bearings. Way downstream from those things, we have steel, but the failure rates on a tire is going to be considerably less than it is on a piece of steel. So don't end up like Construction Careers Academy and build a 16 or 17,000 pound house on a 14,000 pound trailer and go, oops.
Yeah,
That's an expensive oops.
Yeah, we have 12,000 axles right now.
Yeah.
And our
Yeah, yours is
our kind of weight estimate that we did very preliminarily was around 9,000. Like
All in.
All in.
Okay, yeah. I figured about 6,500 on what you showed me.
Plus the trailers, yeah.
Yeah. So I'm thinking all in 8,500.
Yeah. Nate, that's about what we were. Great. I'm glad
I
to
thought
hear
that was a little deja vu.
Yeah.
We already had that conversation. That's why it was so familiar. Yeah.
I'm glad that this doesn't feel like 12,000 right up against.
No.
Yeah, I didn't think it would be.
And consider other things besides MDF. I mean, I know it's inexpensive, but there are wood-like materials that are much less weighty than MDF.
The idea there was
That's a lot
Part
of
of the
MDF.
concept was that it would have weight.
Oh no, you want to counterbalance.
Right.
Because we have, like, for example, 500 pounds of steel on the top, plus the weight of windows and like, that was the purpose of the MDF.
Yeah.
Was the weight.
I think it's a good idea.
Valid point.
Yep.
Absolutely valid point. I'll say no more. It's a good idea.
Cool. Anything else for you guys? I wanted, you mentioned something special about attaching the sheathing to the metals, and that was a specific type of Aerosmith.
Yes.
So we can't just go to Home Depot and get it, whatever.
Not a Home Depot necessarily, but real
Or
close. You
whatever.
go to a commercial supply house, and I have that locally sourced for you, so I can get you in touch with them. We keep 10 or 15 cases on our pallet racking, because a lot of builders call us and go, hey, I got that gun, and I'm doing that thing, but I'm out of those nails, and so is the place that I buy them from. So we're always a little backstop for those guys too.
Just a typical nail gun, or is it?
Yeah, so there's two kinds. Let me get a quick show of hands building experience. If I start throwing around construction nomenclature, Hardy board, Hardy siding, you guys know what I'm talking about? All right, so Aerosmith has two types of guns. They have a 1/4-inch head nailer. These are all 15 degree, which means they're kicked at 15 degrees to your hand. So the head's a 15 degree, pneumatic fired, wire collated siding nailer. So it's a coil of nails. There's 200 a strip. They're glued. They're kind of welded together on little copper wires, and the gun sticks them through there one at a time as you're firing it into your substrates. There's two versions of that pin or nail. One is a 1/4-inch head, 250 thousandths in diameter, that Hardy Siding asks to have shot through their product. Needs a bigger head because it's not quite wood, right? So it can pull, and to match Hardy's pull strength, they wanted a bigger head diameter to hold it down a little bit tighter to the studs. The regular one is just a nail / siding gun, Hitachi, Max, whatever you want, and it's a 3/16 head. It's a 188 head. That's what we use because I use a Max Air A3. It'll feed through a Hitachi. There's a couple others, Hiltis. So most of your commercial off-the-shelf guns will shoot that 3/16 by 1 3/8 nail. I said the N word. It's not a nail. It is a pin. And if I said that in front of Aerosmith's rep, he'd still be here cussing me in Texas or whatever he said. Dang boy, I told you that ain't no nail. So make sure we're calling it what it is. It is a wood to CFS or a pin. Just say a pin. Out in the construction world, on the commercial sites, they know what pins are. Woods for backyard weekend projects, and nails hold that wood together. So guys in the steel world call it pinning.
Quick dumb question.
Yeah, no dumb questions. Probably isn't quick either, if you ask me.
Why would we go with a screw connection versus a screw connection?
It's just faster. I can't say it's better. It's as good. The screw won't back out. I mean, the nail won't back out. I promise you. We've tried. You can't get them to come out. You guys know what a Wonder Bar is? 2 foot, kind of high tensile strength, curved steel bar. We snapped a couple of those like Jolly Ranchers, trying to get the pins out of the steel studs. When we put a sheet on a little crooked, we're like,
But with that said, in a lack of experience, when you want to go with the screw, because if any of you put the pins in, you're going to be in trouble. Anybody makes a mistake.
See, Spencer keeps making eye contact with me.
It's a valid point. The answer is measure twice, nail once. If you don't want that to be a specter, I would say. I like speed and efficiency and technology. That's what my company goes out and develops and discovers. And then we come out here and we talk about it and we share it and we implement it into our processes. So, yeah, I mean the screw guns, Simpson, they've got some pretty decent quick drive screw gun stuff. But nails run circles around it in the time frame. It's like that's about the cadence you can get a Simpson screw into it. And you guys have all heard framers out there, bang, 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 bang. I mean, I just did twice as fast as I can screw it, and that's a lot of screws. So figure out how many hours you want to spend putting sheeting up on the steel, and then maybe decide from there.
Pins go through 2 layers of sheeting?
Yeah, just turn the gun up. For firewall?
We're doing, for structure, we're doing 2 layers of sheeting.
Where?
For the, so to connect that acrylic wall to the other wall,
Okay.
we don't really have even spacing with the studs. because
So use
the windows,
use
so
two,
there's
two layers as a nailer?
Yeah.
Okay. Yeah, it's heavy. But you got weight in, you got weight in the budget, so it's cool. I'm good with that, yeah, 100%. Anything else? Well, I was scheduled to run until 2:30. We can go outside and ask some final questions about the trailer, standing next to it, look at the foam job, the insulation, the why, the how, and the what. And then we can turn you guys loose.
So I have a final question.
Shoot.
We had a question this morning about, we saw the construction of Training House when we visited Trailer Man. And you guys have the amazing gantry crane where you could just take the roof panels and put them up there on top.
Yes.
We're gonna do that in an alternative method, which is very analog, where we've got, 4 ladders and 4 guys, or 6 ladders and 6 guys.
Okay.
Any tips on getting that roof?
Yes.
More of a safety kind of thing.
Kind of. Couple of taglines, up and over from the adjacent wall, span the roof where we're gonna, so what we do is get a couple guys to lift it up and then a couple guys to kind of jack it up with posts. You can slide it up the standing wall, right? And then you got a guy on the back side of it, kind of taglining it into place as guys are pushing it up and whoop, over onto the top.
So a lot of people with sticks inside as well, just doing that.
Yeah. Keep in mind, guys, this stuff weighs a third what steel does, or what wood does. So that whole roof panel's probably not gonna weigh 250 pounds.
Do we need to
So,
worry about?
It's just awkward. Don't let it twist or bend.
Right, over the length of 20 feet, like getting a kink, we're just supporting at the edges and not in the middle.
It's a good idea to have, rule of thirds.
Yeah.
You guys remember that in your photographer class, veterans in here, rule of thirds? So get somebody every third, whether it's a third on the span or a third, on one side of the trailer, somewhere in the middle, and on the other side of the trailer. Always rule of thirds when you're moving these things stood up or panelized. They're not heavy, but until they're connected to their brethren, they're pretty easy to twist up like an aluminum can. You can stand on the thing until you tap the side of it, right? So that's the same principle here. Make sure that we don't tap the side of that aluminum can until we get it stood up. Because once we do, then it's helper strong. It's a space frame, like a roll cage. All the pieces rely on each other. Some of the parts generates the strength.
Cool.
The wiring that you had a question for me on, when you're there, once you get to that, maybe give it a call to me or Kristen. And we live in Erie, and I'm more than happy to come to the job site anytime you guys need me, as long as I'm in town. Okay?
Don't feed the bears, we might, we'll bring you up.
Yeah. So sometimes I come armed with pizza. Sometimes I'll expect pizza. Yeah, I'm here. I don't have all the crystal ball answers. I've seen a lot. We've done thousands and thousands of them now, but I'm sure I haven't seen it all. So if you're the guy that throws me a curveball, then cool. That's one more thing that I've now seen, right? I don't back away from a challenge or a question. I want to know the answer when I'm asked. So challenge us. All right, guys. Let's go outside and check it out, and we'll let you go home, I guess, for the day.